Hi everyone. Thank you so much for joining me again. In this video, I'm going to show you how to do reduction of order when the independent variable is missing. Let's go ahead and dive into this problem. Let's suppose t is our independent variable. So t will be the independent variable. You can use x if you like, but I'm going to go with t. No reason why. You can pick anything you like, really. So we have y times y double prime minus y prime cubed equal to 0. So t is missing. Now, when you have a second order equation and your independent variable is missing, here's what you're going to do. Since we're going to reduce the order, that's what we call it, the reduction of order, we're going to come up with the following substitution. Let v, so introduce a variable, to stand for the first derivative. And in other words, you can write this as dy dt because it's y prime. Now, if I take the derivative of v, so this will then stand for y double prime. So as you can see, if we plug this into our differential equation, you will have a first order equation. Now, since the independent variable is missing from the equation, we need to do a little bit of chain rule right here. So I'm going to rewrite this term. So dv, this is taking derivative respect to t. So this is dv dt. Now, since t is missing, we're going to introduce an intermediate variable, let's say a y. So I can write this by using chain rule from calculus as dv dy times dy dt. So that's just a rewriting of dv dt. Now, if you look closely, this piece right here, dy dt, is right up here. I have that, and we call that to be v. So I'm going to make the substitution, and here's what this is going to look like. dv dy times v, and that's going to be replacing your double prime. So these are the substitution we're going to be making into our differential equation. So v is going to stand for y prime, and dv dy times v will stand for y double prime. Let's go ahead and make those changes. So we're going to substitute in here and in here. So we have y times y double prime, which is replaced with v times dv dy. I just switched the order, minus y prime, which is v cubed equal to 0. All right, so now we have reduced it to first order equation. So this is a first order. And you can use any technique that's applicable to solve a first order equation. I see that this seems to be a separable equation. So let me try to separate the variables. You can divide both sides by v. So you will have y dv dy minus v squared is equal to 0. And then I can add v squared to both sides. So you have y dv dy is equal to v squared. Now you can see that it's separable. So if you didn't see it from the first step, you can now see that this is a separable differential equation. If you need help with separable differential equation, how to solve them, I'll leave a link in the description box for you to check it out. So let's isolate the variables. I want y to be on the right side, so I'm going to divide both sides by y and multiply by dy. So you have dv on the left, and I will also divide by v squared. So you'll have 1 over v squared on the left side. Then this is 1 over y times dy. So I did two things at once. I divided by v squared, that's what I got this, and I multiplied by dy and divided by y. That's how I got the right-hand side. Now you see this is separated, so now we can go ahead and integrate both sides with respect to its variable. So when you integrate the left-hand side using the power rule of integration, you get negative 1 over v. Hold on to your constant, and then on the right-hand side, if you integrate 1 over y respect to y, you get ln of absolute value of y. And now we can put our constant. Let's call it c1. Well, we're almost done, so let me go ahead and rearrange this a little bit. So I'm going to go ahead and multiply by negative 1 and move ln of y plus c1 to the left side. So this will give you negative 1 over ln of absolute value of y plus c1 is equal to v. So this is what I get. And now let's just rewrite them. So v is equal to negative 1 over ln of y plus c1. And now we can replace what v is. We're successfully able to solve for v, this function we wanted. But what is v? So if you look back, v is right here. This is our substitution we made earlier, beginning of the problem. V is dy dt. So I'm going to go ahead and replace that once I finish solving for v. So we have dy dt is equal to negative 1 over ln of absolute value of y plus c1. Now here I can, again, this is a separable equation. So go ahead and separate them. So I will multiply both sides by ln of absolute value of y plus c1. So you'll have ln of absolute value of y plus c1 times dy is equal to negative 1 dt. And now we can integrate both sides. So now go ahead and integrate both sides with respect to its variables. So on the left-hand side, we're integrating ln an absolute value of y. Let's call it dy. So I'm going to separate them into two pieces so you can see why. So we're integrating these two pieces on the left side. On the right side, you can see that's an easy integral. This is just negative t. I would put my integration constant a little bit later. So, but let's go on with this for now. Now, how do we integrate this? If you remember from your calculus knowledge, this is an integral that you need to treat it by parts. So this has to be the integration by parts. Again, if you need help with that or need a little revisit, I will leave that link in the description box for you to check it out. Now this integral is easy. Well, that will just be c1 times y. And then we have the right-hand side equals to negative t. Holding on to my constant. So how do we do this? Well, we're going to be using by part for the left-hand side integral. We pick a u and we pick a dv. So I'm going to pick u to be ln of natural log of y. Now here, to simplify a lot of the stuff, you could remove the absolute value and assume y is positive. I'm going to carry along thinking y could be anywhere, anything really. So I'm going to keep the absolute value for now. So then the derivative of u will be 1 over absolute value of y. Then dv has to be dy. So then v, when you integrate dy, you'll have y. So now using the integration by parts formula, this becomes the integral of u times v. So y, ln of absolute value of y, minus the integral of v du. So that's y over absolute value of y dy. So I did forget to write dy right here. All right, so now we're going to finish up this integral right here. Now this, again, you can break it up into two cases, if y is positive, if y is negative. If you assume y is positive, then this integral would become negative the integral of y over y dy, which is really negative the integral of 1, because y over y will simplify, dy equals to negative y. Holding on to my constant, so our final answer now will be the following. So it's this, with this from before, and this. And we're going to add another constant to it. So if y is greater than 0, our solution is y, ln of absolute value of y, minus y plus c1 times y from above equals negative t plus c2, another integration constant. That's what we've been holding on to. Now, this is a nice answer. If you would like, you can stop here, but we can make it better. And also, I'm going to come back to that integral where we only assume y is greater than 0. So these pieces right here, they both have y. Let's factor it out. So you have negative 1 plus c1. And you can call this a constant, call it a c. So your final answer can also be written as y ln of y in absolute value. You could remove the absolute value, like I said, and then this is just plus c times y is equal to negative t plus c2. So this would be a better answer if y is assumed to be positive. Now, again, I'm going back to this integral one more time if we assume y is negative. So if we assume y is negative, then this integral will be treated in the following way. So let's take this again down here. So if we assume y is negative, then this integral will become negative, the integral of y over negative y dy, which will turn out to be a positive 1 dy, that's just y. So here, when we replace it with negative y, it becomes just y. So this is how our answer is going to vary. So I will take this answer and show you how this varies, but really not a big change, as you will see. So if you assume y is negative, so if y is less than 0, then our solution is, so this I replace it with a positive y, and then c1y equals to that. And then again here, you can pull out the y's. So you have y ln of absolute value of y plus y times 1 plus c1. Again, 1 plus c1, call it another arbitrary constant. Let's call it c times y equals negative t plus c2. So there you have it. This is the answer if you assume y is less than 0, which is not a different answer from the one we just obtained right here. So you are free to assume that y is positive, and it will make more sense if the question was clear to tell you y assumed to be positive. So there you have it. That's how we treat problems where the independent variable is missing when you're doing a second order equation. All right, we'll see you next time.